Now, turning to our next session, we will look a bit more at how standards can evolve to meet future needs. We've already heard a few times the references to the EUROCAE and RTCA working group special committees. So Chris will discuss with his panelists a bit how we can be responsive to the industry needs, because in the end, we do all of the work that we do for the industry and the stakeholders. Whether there are any improvements and developments that can be considered in our standards to make the use of the spectrum more robust also from that angle. Chris is a technical fellow with the MITRE Corporation and has been chair of the RTCA Program Management Committee, the PMC, and also of ST159 on GNSS since many years. Over to you, Chris.
Okay, thank you, Anna, and good morning, good afternoon, good evening to all of our panelists and participants and attendees. This session, again, is entitled How Standards Can Evolve to Meet Future Needs. And as we've heard about over the last couple of days, RTCA and EUROCAE have an activity that's been underway for about a year now to look into this. This activity is being led by a new RTCA special committee, SC242, chaired by Ed Hahn, working jointly with EUROCAE's Working Group 124, led by John McCullough. And we're fortunate to have a lot of the leadership of this joint group here with us today. We have Ed Hahn, again, the chair of Special Committee 242. He's a senior engineer with ALPA. And we have John, who's a spectrum expert at EUROCONTROL's Network Management Directorate. And they'll be joined by Subgroup 1 lead chair of this group, Andy Roy, who's the Director of Engineering Services with ASRI. He's also the chair of ICAO's Frequency Spectrum Management Panel. And then last but not least, chairing subgroup 2 of this group, we have Capucine Miel, who is a PhD from ENAC in Toulouse and currently working with Airbus. So I'll hand over at this point to Ed first, and we'll go through these folks in order here with some opening remarks before doing some question and answer. Over to you, Ed, please.
Thank you, Chris. Next slide, please. So as Chris mentioned, we are working in this new special committee and working group with EUROCAE and RTCA. To kind of give an overview of what the committee is trying to accomplish, I'll first start by saying that the historical purpose of standards, whether they're minimum aviation system performance standards or minimum operational performance standards, these documents are really written for, historically have been written for manufacturers. The requirements and the performance levels specified in the standards are there to meet an intended function. And I'll give an example of what that means. And that the performance requirements are also specified to mitigate hazards. So when we talk about standards, a regulator such as the Federal Aviation Administration will typically do what they call invoke the MOPS or MASPs via something called a technical standard order, which essentially tells the manufacturer exactly what they need to do in order to certify a piece of equipment. The technical standard order also specifies the level of design assurance needed to mitigate the hazards based on the what the regulator assesses the hazards associated with the intended function are. It's important to recognize that these documents are written to be the minimum performance standards needed to accomplish a given function. And this is really to preserve the manufacturer's ability to innovate within those constraints. That word innovate within the constraints is something that other industries use those same words when they speak about what they would like to do and therefore why they don't want to be constrained. So aviation in that sense is no different when it comes to the use of the spectrum. Next slide, please. So as an example of intended function, the radio altimeter is certainly a well-known topic at this point. As it's used in, for example, air transport category, category 3 auto land, that can be a landing with essentially no visibility forward when the aircraft can actually land itself without visible reference to outside. As you can imagine, this is a pretty challenging operation, and the pilot is really realistically not really able to intervene in time if, for example, an undetected malfunction of the radio altimeter system occurs. And because it's such a critical function or operation, the hazard severity has been established as catastrophic in this case, because if there is an undetected malfunction, it's likely that the aircraft will have a hard landing or other even more serious result. One of the ironies here is that because radio altimeters have been so reliable over the last 3-4 decades, the information that they provide has also become deeply integrated into other aircraft functions. And this includes things such as arming and deployment of ground spoilers, auto brakes, thrust reversers, and even in changing the handling qualities of the aircraft as it approaches the runway. So in some sense, the disruptions we're seeing now, at least in the United States, are kind of implication of the reliability that radio altimeters have historically had, and therefore it's somewhat a victim of its own success. Next example, please. So the radio altimeter, the last time the standard was revised for radio altimeters, it was 1980. As such, I've extracted the only paragraph that talks about radio performance from the MOPS, and I think, as you can see, there's not many numbers in that paragraph. The ITU, or International Telecommunications Union regulations that is referred to in this paragraph have a similar problem as MOPS, as they have not really been kept up to date. So one other aspect of radio altimeters that's maybe different from the typical communications function or even navigation function is that radio altimeters are self-contained functions. They don't need to interoperate with other radio altimeters or other systems that might be located on the ground. And the main consideration is that they don't interfere with each other when you have multiple installations on an airplane. This is an example, unfortunately, of the fact that considerations for spectrum compatibility have not historically been specified. Next slide, please. So that kind of is the motivation for what SC242 and Working Group 124 are up to. Looking forward, we see that the demand for spectrum is increasing rapidly by all industries, and that aviation needs to consider spectrum compatibility as we create new and revised standards. But even then, that's a great objective. But that cell phone on the right there is a Motorola Dynatac 8000 from which was the first commercially available mobile phone, and that wasn't even sold until 1983. So the question is what should the designers of radio altimeters standards have assumed in that adjacent band, especially back in 1980, which predates even the deployment of the first cellular networks. And even now, 2 years from the auction of the C-band in the United States, aviation is still trying to nail down the exact adjacent band environment globally so that the next version of the radio altimeter MOPS can be written. And by saying nail down, I will point out that, for example, several countries do not even specify a C-band power limit for their 5G deployments. I'll hand it off to my colleague, John McAuliffe.
Thank you, Ed, and I'm grateful to RTCA and EUROCAE for extending their invitation to me to be part of this panel. So, taking on the baton from Ed, in order to articulate the brief that this joint committee has, I would like to circle back to the very nature of spectrum. So, next slide, please. And I think we need to be reminded from time to time that in the end of the day, radio spectrum is energy and therefore chaotic by nature. It spills over international borders. It's a well-known cliche by now, causing all sorts of issues, but it remains a hugely important and useful resource. And therefore, to impart some sort of order to this chaos, there's a number of catalogue of technical and regulatory measures in place. So what I'll do next is, in linking standards in this debate, I would like to, first of all, get a couple of caveats up front, just to make it clear what we're talking about here. We are not being tasked in this joint committee to develop standards per se, but we are developing guidance for standards developers. Neither is it our intention to provide an ultimate critique of all standards out there in existence. We are, in fact, cataloging what's currently available in these documents, identifying gaps in the radio specifications with the help of with the radio experts who are participating in this committee and in other companion committees, and offering sort of plain language guidance on how to close those gaps. So with that out of the way, many of you would be wondering why I have a sort of a chart up here with one of a few of these sort of well-known automotive institutions. So bear with me on that. So the anecdotal comparison that's often drawn up with spectrum as a scarce resource is that with other scarce resources like energy. So back a few years ago, Professor Martin Cave of the UK compared coal with spectrum, calling spectrum what spectrum is to the 21st century to coal what coal was in the 20th century. I'm going to take a slightly different slant on this, with comparing spectrum in some ways with real estate. I'd like to invite you to sort of take a look at this chart in front. So you've got a big building, lots of big open spaces, a desert. You know, spoiler alert, this is Dubai back in the 80s. So going back memory lane, as Ed did in one of his charts, nostalgically. Next, please. And next again. 1985, that was. So next, fast forward to today, well, not quite today, but near enough. The eagle-eyed amongst you will notice that that building is still right there. A lot has gone on in the immediate surroundings. The road is still there. Noisy, chaotic, many new neighbors. There's a lot of draw on infrastructure and on resources, whether it be space, energy needs, access needs, etc. And there's a few very important parallels I'd like to draw here, and one which I'd like to make in my more recent presentations on spectrum. And I'll transition them one by one because I'd like the audience to go away with these messages sort of firmly in mind. Next. First is that spectrum is a long game. Evolution takes quite a long time to happen, but when it does happen, it happens very suddenly, and that change is irreversible. Next, please. Few economical imperatives for spectrum. It's a grand old economical game, is that when demand outstrips supply, you start sharing. Guess what? You start subletting. And this is what's happening in some parts of the spectrum bands, and aviation is no exception. It might happen in some pockets of jurisdictions, and most notably in the UK recently in the L band, but this game is coming. We just need to be prepared for it. Next, please. New neighbors have differing requirements. You can see in this picture, it's quite chaotic, but there'll be a different set of draws and needs on the local infrastructure. The local environment is key, and that's a point I'll make throughout my brief here. And last, next, please. When the environment changes, guess what, guys? The ground rules change as well. And we need to remain relevant in that new world order. One of yesterday's panelists quite rightly said, spectrum compatibility is often an insidious matter. I mean, you don't know what you don't know, and to the point that you often don't know something up until the point something actually goes wrong, and then it's too late. And this touches upon one of the key tenets of aviation, that of safety. It was brought up yesterday, and I just want to sort of take opportunity of this to sort of remind the audience that make no mistake, that remains a primary goal for the aviation stakeholders, to ensure that the use of spectrum remains efficient and safe. Next chart, please. So what do we do about this? And I mean, where do standards come in? So what is it that we're being asked to do in this joint committee? The intention here is to take sort of a step back and take a strategic view of where we're going with comms, navigation, and surveillance systems. And to me, the zeroth step, the very start, is in determining how aviation standards could, or perhaps should, evolve in order to understand where they came from. And recognizing that some of these CNS systems that sometimes we take for granted on the aircraft and equally on the ground have been there for a very, very long time. Many of them before my time in my profession, many of them before me, period. And taking a look back at what I presented in my previous chart, these standards for these CNS systems have been laid out in a very, very different spectrum neighborhood. It's key to keep this in mind. So it's important, one of the key aspects in order to transition our standards to a new world order is to keep our house in order, keep our own house in order, and present a coherent front when we discuss radio spectrum matters with other sectors. At this stage, I would like to draw a comparison, and maybe drawing on what Ben Brandt said yesterday in his presentation, that collaboration with other sectors is key. And he's dead right. But we also need to be speaking the same language. My personal insight from recent discussions with other subgroups and the Red Alt and 5G parties is that there's a lot of goodwill, but we don't always speak the same language. And we're trying to address this. So a big focus for this joint committee, and this is where Ed and I are completely aligned on the RTCA and EUROCAE sides, is to bridge this gap and to facilitate productive exchanges, be it with the ITU or regional groups like the CEPT. We had a presentation from one of the chairs of the project teams yesterday. And this is by developing a handbook that cuts through all the complexities, cuts through the language, the acronyms that we love using in aviation, but also explaining the way we develop radio systems from a safety perspective. Make no mistake, this relies very, very heavily on resource, expert resource, spectrum experts like those gathered around this virtual table. On that point, next slide, please. So who are we? But what are we being asked to do? I will not go into the detail of this because this will be to the next distinguished panelists to speak through what each subgroup is doing. So we're a group of 45 international industry contributors. So this is heavily contribution-based, as with all the EUROCAE RTCA subgroups. And it relies on expertise, radio expertise. Now, looking at the lists of the panelists here in this very session, and also the list of there's a few hundred participants in this forum, we're all accounted for. It's not a lot. So we need, and one of the points made yesterday in the chat comments is that we need more people involved in spectrum in aviation. It's a point that rings very true. So we're a group of 45 international industry contributors, but boiled it down to when we sort of do the work, we're probably a couple of dozen who are actually actively contributing to the development of this handbook. In terms of the highlights, the goal is to ensure that we have all CNS systems have a complete specification and protection criteria that actually fit and fit for purpose for the environment that we know about today, and projecting this also to the environment we're expecting to deal with the tomorrow and the day after tomorrow. Needless to say, the products will be a couple of guidance documents. They are not standards, but guidance documents and the reports on the characteristics for radio parameters and best practices to close these gaps. I would think I will leave this at this stage in order to give some airtime to Andy, Roy, and Capucine to take on the detail as to how we're going to go about this specifications. Thank you. Back to you.
Great, thank you, John. So from the work that we've split up to, as John alluded to there, we have subgroup 1, SG1, which is the work that I'm leading with at the moment. Next slide, please. And SG1's task is to really figure out from the start, effectively a baseline of what do we have, to put it the most simple way forward, on what then can we use with that and what has been raised from what we have already to support the guidance document and the work that will fall out from it. So we've basically begun a survey of all the RTCA and EUROCAE documents and standards to assess what we have from a radio frequency RF perspective. And so from that, we have at the moment 78 documents that we are looking to survey from the relevant experts to understand what is in the document and what's going on. I would caveat that we've tried to keep it to active equipment. So if there is still standards that are technically active at the moment, but they're not really used in mainstream aviation anymore, we're not doing those. But from that list, we have 78 total documents we're reviewing. That's been split between the currently active special committees and working groups, i.e. those that have memberships that are working on something at the moment that are available. And we also have what we call the inactive special committees and working groups where they're not in session at the moment. There's not a formal membership. And so we've been trying to reach out to necessary experts or even ourselves in 242, 124, work on the existing standards and pull the details out from the survey. And the survey is really looking at spectrum suitability, because if you sort of take a couple of steps back and look at spectrum and the use of standards in spectrum, RTCA and EUROCAE standards really have the most detail possible that we can find often for many aviation systems. And that is what is needed often to do spectrum compatibility assessments within aviation or externally. And so they really do form a core basis for the information. At the same time, though, alluded to what Ed talked about at the start, they are written not for spectrum compatibility, but they're written for manufacturers to design against, build against, and test against, and obviously for civil aviation authorities to certify against. So there's a bit of a dichotomy here about asking for how suitable they are for spectrum when many of those standards were not written for a spectrum consideration at the time. So very much in the survey, we are not trying to say whether a standard is good or bad. What we are really trying to do is look for how it's defined the performance, understand how it's been done, and is there any examples that may help us in spectrum guidance. And to split that down into sort of more specific areas, really the survey looks at the radio frequency functions, so the transmit function, the receive function, if there is any antenna parameters as well that may be useful, and the installation characteristics. What is also included in the survey, which can sometimes be the more interesting component that we're after, is guidance, recommendations, or simply lessons learned from those special committees and working groups that have been involved in spectrum or sometimes even been burnt with spectrum activities before, about what they did and why they have done that in particular roles. And a great example of this would be GPS. DO235 has a lot of material on considerations for external interference to GPS receivers. And so we're very keen to understand from Special Committee 159 and its EUROCAE equivalent about what they have done and what they have learned to help hopefully provide information to other special committees and working groups on best practice and what has worked and what hasn't. By the end of this, the final product from the SG1 is really not intended to provide any answers directly, but it is intended to provide a catalogue of what we have and the questions that have been raised, with the idea that can be given to SG2 and Capucin's group, which we'll come on into a second, to help inform areas that we may need to look at going forward, or things that we have seen that may be of use, rather than the group trying to effectively reinvent the wheel in certain areas if that's already been experienced. So I'll hand over now to Capucine to delve into more SG2 work and how SG1 will help that.
Thank you, Andy. So that's a good transition towards SG2. So Andy always says that SG1 is in charge of raising questions and SG2 is in charge of answering to them. So what I'd like to give you today is to provide you an insight of what we are doing right now and what we are planning to achieve. So if you go on to the next slide. So basically, the SG2 is in charge of a new guidance standard. So the idea is to propose a kind of canvas or a template to support interference assessment and interference resilience. Then this canvas will be brought up to other committees. So they will have the opportunity to appropriate the method and to adapt it to their particular system. The idea is to stay non-system specific and as much as possible non-technology dependent. We are also going to contribute to the harmonization of radio frequency parameters definitions across RTCA and EUROCAE. And there's plenty of recommendations that are already available within ITU, ICAO, and CPT. So the idea here is to be able to provide recommendation for new standards in case there are new signals that are coming in the way. So our starting point will be what's already inside EUROCAE and RTCA documentations. So there are good practices, but there's also some parameters that are missing or with definitions that are not adequate for interference assessment as they were done for performance assessment. So from ND survey, we are going also to have a lot of questions raised by experts. And the idea will be to try to address them or at least to say in which direction the answer can be found. So we will base our study on already existing recommendations. So ITU, ICAO, and CPT, as I mentioned. We will also bring our expertise of radio frequency specialists. Once our guidance standard will be ready, we will be able to help other committees in order to try to help them to appropriate the methods. We will be there to help them and to answer to their questions. It will also be the opportunity to gather feedback from them and so we can start to see if there's need for a new issue by then. So if you move on to the next slide. So here you have our working plan, so a very detailed one. So for SD2, we are planning to deliver our standard by September 2024. So there's a lot of different topics to address. We divided the work into 9 information papers that will be filled all along the way. So they are kind of all related to each other. So we decided to sequence that into 2 batches. So the first batch will be about a general description of transmitter and receiver. So for example, the first information paper will try to acknowledge the question and the RF survey from SG1 and to direct the answer towards particular information papers. Then we will have the opportunity to bring spectrum envelope, so for transmitter and for receiver. These 2 ones will be built jointly in order to ensure that they are interoperable with each other. Then we will have another paper about decision criteria. So this one will give us thresholds that should be assessed for interference assessment. The 5th one will be about interference scenarios. So in which case are we going to apply our envelope and our thresholds? And the last batch, which is highly dependent on the first one, there we are going to establish our methodology in order to put all our 5 first issue paper together and to propose a method to check if there's risk of interference or not. We will have also a paper on measurements because we are going to ask for radio frequency parameters. And so these ones will have to be measured. So we will provide recommendations as well on that. And there's another quite interesting topic we are going to dig into, it's margins. So we have as objective to try to have a detailed and justified margin link budget. So this one will be quite a large task to do. And the last information paper will be about interference reduction techniques. We are willing to try to check what can we do in order to reduce the risks. And so that's all I had on my side. Just want to emphasize on what John said. We are really willing to have more volunteers. So if you have any radio frequency knowledge, please feel free to join. We will be very happy to have you on board. And so that closes my talk. So I can hand over to you, Chris.
Hey, yeah, thank you very much, Ed, John, Andy, and Capucine. You very nicely framed some of the challenges that RTCA and EUROCAE face with their standards work regarding spectrum, and also nicely outlined the plan that's being followed by Special Committee 242 and Working Group 124 to address these. I have a number of questions, and we have some time for questions. And I'd also encourage anyone in the audience, if you have any questions on these topics that were framed in the opening remarks, to please type those in the web tool, and we'll try and address those to the extent that we have time to. Just to start the discussion here, Ed, you had mentioned how radio altimeters are really somewhat of a unique aviation system in that they are self-contained. There's no specs on what the transmitted signals look like, or very few radio frequency requirements aside from the band. And that has led to some great challenges that our industries suffered with over the last couple of years here. In the work that the group has done so far, have you identified any other systems that have those same characteristics?
Yeah, so another one that immediately comes to mind, I think, is the weather radar. Those, again, are radar systems. They're not communicating or interoperating with any other systems other than themselves. And therefore, there's kind of a lack of specification about how the receiver ought to be designed, and other characteristics like waveform and other things like that. What we've noticed is that older standards tend to include things like receiver masks when they were implemented into a known challenging environment at the time. So for example, VOR includes a maximum level of undesired signal right at the band edge of 108 megahertz because of the well-known FM broadcast potential for interference. But aside from that, it's pretty mixed as to whether a standard would really have specified a receiver mask.
Yeah, thank you, Ed. And it's interesting because the telecom industry has expressed an interest in creeping up into some of those mid-band frequencies used by the weather radars, so something to keep our eye on. Andy, for aviation systems that do have defined masks or at least some RF requirements, has the group made any preliminary findings on potential issues of compatibility?
So not potential issues, obviously it's very scenario dependent, but I would say one of the questions that's been raised up is with what we've been seeing recently with the various systems being talked about around aviation system spectrum is to do with defining your transmitter mask and your receiver selectivity mask. And the fundamental question that sort of seems to be coming up when we're dealing with it is how far away should you specify that? And what happens when you reach the end of that specification point and go beyond that? Is it assumed that everything can work out at that? Even though power versus distance, boiling down what spectrum compatibility is, there's always going to be a certain threshold you can, you're going to hit. And certainly in my view, seeing what's happening now with the spectrum and the changing environment, and we've seen some suggestions being talked about of 88 dBm EIRP transmitters, which is effectively emitting over 600,000 watts of power. And if you consider an aircraft may get significantly close to that within 10 meters or so for certain aircraft operations, trying to sort of anticipate, well, maybe it's going to be higher and maybe we need to start looking further out from just the adjacent band for what we're doing. And again, in my view, we need to balance that by also maybe external regulators thinking we're maybe trying to protect too far out as well at the same time. So I think there's going to be an interesting question when we get into the SG2 work under Capucine's area about what should we be recommending for how far away from your intended band of operation should you be defining And once you reach that limit, what happens there? Is it HERF? Is it other aspects that need to be considered as well? So certainly it's going to be a long discussion, I think, when we reach that topic.
Yeah, a lot of challenges there. You mentioned, I guess, one parameter that I've noticed has been really hotly disputed in a lot of compatibility discussions between aviation systems and other systems like telecom systems. And that's the distance between that an aircraft could actually get, for instance, to a cellular tower. If the aviation industry and regulators can't come to agreement on that, it's really difficult to actually ensure safety of aircraft. Capucine, any ideas that have been discussed so far within subgroup 2 on how to develop a consensus on that and some of the other parameters that Andy mentioned?
Well, for separation distance, I think that could be one of the outputs that you will be able to withdraw from our methodology. So the idea is to consider the receiver and the transmitter as a whole system and not just focus either on the antenna or on the transceiver. So if you consider the system as a whole, you are able to provide an envelope mask. And then if you have both envelope mask and if you follow the methodology that we are willing to produce, then I think you will be able to have a kind of theoretical separation distance. You will, of course, have still some assumption. For example, we can mention far-field hypothesis for electromagnetics, because we are not going to consider everything that's on the aircraft structure, for instance. So from a theoretical point of view, you will be able to retrieve minimum, at least a separation distance. But of course, it will stay a standard. So the actual performance of our CNS systems will be always better than the standard. So the reality will be a little bit better than what we will recommend. But that will be quite useful, at least for a new system, to check if they can be airborne in their current state, or if they have some parameters that should be reworked. So that's still a good first clue.
Okay, thank you. One thing you had mentioned, John, was on how we really have a disparity in the timeframes between telecom, where things can happen very abruptly, and in aviation, where our standards take a long time to develop. Do you have any thoughts on what we can do in the near term in order to improve what we're doing within RTCA and EUROCAE and aviation community at large?
Well, yes, Chris, actually, yes, standards do take a very long time to develop. We are getting better at it, but we are, in a sense, jumping on a bandwagon. Like spectrum standards is a long game. However, in order to sort of be better prepared for the next ITU study cycle, and I'll invite the audience to sort of have a look at the pre-recordings where we explain and explain the differences in the ITU cycles, what needs to be done between each cycle in order to sort of put a favorable case forward for aviation, but also determine the sort of studies that need to be made to understand what compatibility studies are needed. We're cognizant of all that, and we got to incorporate we started this group beginning of this year, so we are pretty much well established, but there's a lot of work ahead. In terms of where we're sort of setting the crosshairs on, a couple of in our terms of references, we've got a couple of deliverables coming up next year, and one final one in 2024, as Capucine mentioned earlier. And we are trying to ensure that the community is prepared, geared up for the next study cycle. So we've got the World Radio Conference coming up in Dubai in November next year, so it's nigh under a year. From then on, there will be the following study cycle, and they tend to come in 3 to 4 year cycles. We want to be able to produce and publish these documents in good enough time so that the conversations, the likes we're having, or we've been having these last several months and years with the IMT industry, with the radio and the radio altimeters, for instance, that we can empower those actors to have meaningful and also productive conversations. When those conversations happen in be it, like I said, the ITU, CPT, or other regional groups. In terms of the structure and what we're trying to head for, The environment has changed, as I think I've labored the points during my presentation. So we're trying to ensure that when developers are looking at the radio specifications, the characteristics, they're looking more at things like, and I'll just bring one example up from the L-band. It's a very highly pulsed environment. We've got secondary radar systems there, ADS-B, we've got DME, all very highly pulsed. Throw in there in that mix an upcoming aviation data link communication system like LDAX, and what's happening also, not in our band, but in the nearby adjacent bands. They are spread spectrum systems. So we need to be able to specify, articulate protection criteria that protect pulse systems from non-pulsed or spread spectrum systems, and vice versa, something which wasn't in the previous environment. So these are the kind of things we'll be looking for in terms of content.
Okay, thank you. And actually, on related to some of the comments you just made on the importance of talking with the telecoms and others, as well as the cry that's been made a couple of times for additional spectrum experts within your group, have you had the regulators and other external stakeholders participating in SC 242 and 124, and if so, to what extent?
Look, we're not in a bad place. We like I said, we've had a sort of strong 45 membership. 45 organizations, most of which are quite active. We do have a few regulators among them. We have the USA, UK, France, Germany, and a few others. And that's great. We also have emerging users. We've got some folk from the ARPAs and the drones sector who's helping. And we don't have, as far as I can make out, any direct participation from telecoms companies, but I think there might be one. It's important to also specify that. And to the point I made earlier, we need more spectrum expertise in the sector at large. Most of us are around this table, be it on this side or in the audience. We need to make sure that we are kitted up and that there's enough resource. And which speaks to one of the points made yesterday by one of yesterday's panelists, that spectrum is getting a lot of attention also in higher management, which is very important, so that there's enough investment in this area. In terms of the expertise that we're using directly in the group, we are using in-house as it were contributors from those who are actually actively involved in this joint committee. But for what Andy said earlier on, we're also dishing out information and asking for information from other companion committees, those who are developing standards for specific systems. And we use a number of channels to get out of them. At the moment, we're preparing surveys. So the expertise is quite broadly spread. But I think in terms of circling back to your question, we've had quite a good contribution so far, and I really do sincerely hope it's kept up. It would be really good to have more regulatory input so that we can test our documents as we go along in this development process. Back to you, Chris.
Yeah, thank you. I'm noticing we're at the end of time here. I'd like to thank very much all of our participants in this panel, the leadership team from SC 242 and 124. And I'd also like to thank all the other members of those groups for all your contributions. This is certainly a very important role that you're playing for our industry, and we thank you very much for your time on these efforts. Anna, I'm not sure if you're with us now, but we'll hand back over to you. And thanks again for the audience for your attention.